Hey, what's up guys? In this video, we will have an overview of what Ansible is. We will use Ansible to set up and deploy SAP instance as a container on Linux and in a VM. Ansible is an open source software provisioning, configuration management and application deployment tool enabling infrastructure as code. In Ansible, there are two categories of computers, the control node and a managed nodes. The control node is a computer that runs Ansible. A managed node is any device being managed by the control node. Ansible works by connecting to nodes on a network and then sending a small program called Ansible modules to that node. Ansible executes these modules over SSH and removes them when finished. The only requirement for this interaction is that the Ansible control node has login access to the managed nodes. While modules provide the means of accomplishing a task, the way we use them is through an Ansible playbook. A playbook is a configuration file written in YAML that provides instructions for what needs to be done in order to bring a managed node into the desired state. Playbooks are meant to be simple, human readable, and self-documenting. A playbook can be very simple, such as this one that installs Docker and deploys SAP ABAP 1909 container, or a complex where entire Docker Swarm cluster can be deployed, scaled, and maintained, like what I did for OpenCart on HANA, which you can find a video here or here. So let's get started. So in a multi-container deployment scenario, we don't have to, or it's not necessary to log on each system and then you deploy a container, or you build system from scratch and then deploy a container on individual systems. Rather doing that, we could use a control node and then we manage nodes in collective actions by using Ansible. So the first part is what we are going to build is, first we have a control node, which is my laptop, and then I have prepared 3 managed nodes. Let's give their host name. It's called SA01, one managed node, 2 and 3. So this is SA2, and then this is DSA3. So these 3 nodes are mixed types, meaning these 2 are Lexi containers and this one is a VM. It's a Debian VM. My control node is running Linux. Again, it's a fork of Debian, so it's a Debian distribution in short. Now my control node will execute programs on these nodes and it will install ABAP Docker container. So the way it works is it will send small programs to these nodes. Ansible will send these small programs to perform actions or to maintain a state of an application. So for that, like I said, I have these nodes and we are going to deploy ABAP container. So this is my Ansible playbook file. Playbook is simple, it's YAML file, so it's straightforward. And just to give you an overview, first we have a name, so we gave a name for this playbook. Then this is a variable to declare a few packages required as prerequisite for a Docker container. Then there are a bunch of tasks. So tasks are the activities in a normal scenario we perform them on individual nodes. So in here Ansible will perform for us. So the first task is to update package index, then find out who am I. This is to just capture the user, so we can add that user to a Docker group. Then find out, and then this task installs all the prerequisite packages listed there. The next command is to get the distribution type. We need distribution type to pull a Docker from Docker repository. Then add a GPG key based on distribution. You can see it here, the distribution use. Then find out the release and then use that release to add Docker repository. Then again, once we make any change in the package repository, we have to run a package index update, which is apt update. So we run that again. Then we install Docker. After installation is complete, we will run Hello World application to test the Docker installation, and this one just prints output whatever happened here. Then create a Docker group. If it is already there, this will be ignored. Then add the current user as part of a Docker group, so we don't have to use sudo command to run Docker. Basically, you are part of Docker group, so you can use Docker as a regular command. This one is to log in into Docker Hub, because ABAP container is not accessible or not available to download anonymously. You need to log in a Docker Hub. So Docker Hub user and a password, you can pass it through the arguments, Playbook arguments, and those will be used here. Then this is again output. Then verify existing container. So if we already have a container, let's say we run 2 times the same playbook. So on the first run, it will create a container. But if we run again, since the container already exists, it will throw an error saying the container already exists. So to prevent that, what we do here is we find out if our container, basically this is the container which we are going to deploy, which is A4H. So in this command, docker ps-aqf name A4H will give us a container ID. That means the container is already deployed. And if that is the case, then don't deploy, then start the container. This is kind of a branching if-else statement in Ansible. So we determine a state here, and then we use that state in a later part to put a condition for a task. So which you can see it, when valid is initial, that means there is no container. Then perform docker run, that means create a container. But if there is a container already, then don't perform create a container or docker run, rather start docker container. So this is just a conditional branching which we can add. So basically that's all we have in the Ansible playbook. All we have to do is just run this playbook, and then when we run this playbook, it's going to deploy a container in 3 systems. And I'm saying 3 because this is the host list. Probably I just skipped, but host is the host file in the control node where we can maintain hosts, or rather the host file in a control node is the source of the systems where we will be running this playbook. So host can have a group of hosts. So SP909 is a group. Under that group we have 3 systems, and I'm going to show you that too. So let me first do my user. Okay, so and let's maximize. Let me zoom a little. Okay, nano. So I'm on a control node, which is basically this laptop where I'm where I will be running Ansible. So Ansible configuration or host file is in etc Ansible hosts. Now under host, you can create groups and you can maintain host entries under groups. So for example, my Proxmox group has 2 hosts, or my SP909 has 3 hosts. These hosts are the machines which are running VMs or LXC containers or whatever it is, or a bare metal. So now going back again, this is our playbook, and those are the hosts. These are the hosts. So when we deploy our playbook, it's going to create container on those three systems, 2 containers and 1 VM, and it will deploy a ABAP container. Now to make this video faster, I already pulled Docker image, so you will not be pulling it now. But if you are running very first time, it may take a very long time because ABAP container Docker image is about 27 GB. So just to save time, I already pulled it. So let's run our playbook. Let me move that here, here. So all I need is Ansible playbook. Okay. Okay, so yeah, we'll do it one more time. Copy. Just that the thing bothers me. Okay. Now this is how we can run playbook. Usually running a playbook is fairly straightforward. You type Ansible playbook, you provide the playbook name, and that's it. You hit enter and it will start deploying, or it will start running playbook. In our case, which I showed you earlier, we have a Docker user and a Docker password arguments we are using in a playbook, and these will be supplied through as an argument. So instead hard coding them in directly in the file, we prefer to pass it here, and here we can store them in the system variable, environment variable, which we can find it here, Docker login. So you see that the Docker password is the Docker password here, and then we have another Docker user variable which is here. Now I already set these variables to my Docker user ID and Docker hub user ID and a Docker hub password. So let's run now this playbook. Now since we are maintaining a state, the first thing it does, it checks state for each task in the system, which we can see it here. The green ones means those states are already maintained. Yellow means those states are changed. Now fail to change kernel read-only file system setting parameters. Okay, so I ran okay, let me, oops, Control Y, save. Okay, so we have a small problem. 03 Docker PSA. Okay, so it's running. The container is active and is starting HANA-DB, so we don't want that. Docker stop stop A4H. Okay, so the thing is, when we deploy our Docker container, and let me show you, let me switch back here. Like I said earlier, we have 3 hosts, 2 containers and 1 VM. When we maintain kernel parameters, they differ based on containers and VMs. So for VMs, they are straightforward VMs like any other operating system, and you can set their kernel parameters in the operating system and there is no problem. But if it is a container like LXC container, which I'm using, container is running under a host environment. It does not have its own resources. It's just using a namespace. So you cannot really change kernel parameters being in a container. You have to change kernel parameters in the host operating system, and then you can use those kernel parameters in the container. So what happened is, since this script, I ran a deploy ABAP 1909, which has kernel parameter entries here. These are the ones, and they are supposed to be maintained into etc/syscontrol.conf, but we are in the container, and since we are inside container, we cannot set kernel parameters for the host operating system. Basically, this is mounted as a read-only. That's why it failed. Now, how do we fix it? Well, we have to separate our containers and VMs, and We could just ignore that flag. We could do that. Ignore error. I think it's called ignore error. Here, if we say ignore error true and save. So it will try to set there, then we have to say ignore error true. Where else we need syscontrol, that's output. This one is the configuration. Then these are standard, no change. Okay, it seems to be okay now. But the container, but the VM did not stop yet. So let me log in on SA01, SA03. Let's see, follow. Okay, you are trying log 10 times until initial termination. Docker container must have at least 16 GB of RAM. Container must have at least return to continue. Okay, so our container did not stop for whatever reason. So let's say docker rm will try to remove that container. Oh, we have to stop. Okay, now we can get rid of the container. Now if I say docker ps-a, we should not have that container. Okay, it's gone. Okay, come out and let's run it again. Now the only change we made for now is ignore error on setting kernel parameters for the containers, and there are two tasks which basically play around with the container with kernel parameters. Here we set kernel parameters, and here we load them into, we make them persistent by running syscontrol man -p. So I said ignore both of them. Let's try again. Conflict, ignore error appears to be in, but maybe elsewhere in the file depending on exact syntax problem. Name configuration parameter, name configure kernel parameter, name configure parameter. Yeah, that's what we have. Ignore true. Say, let's see. Apparently there is a syntax error. Okay, still we have an error. Ignore. What is breaking? Yes. Ignore error should be yes. Okay, my bad. Not true. Yes. Save and clear. Let's run again. Of course, this needs a password. Okay, again we have error here. Ignore error. Ignore errors. Okay, errors. Okay, that would be ignore errors. Let's give a try. Okay, it worked. Okay, PGP add is fine, update packages is fine, install Docker is already installed. We said ignore errors, so no change in there. Start existing containers skipped, and then we see a container being deployed. These are the kernel parameters we just ignored for containers. Now we can log in on individual systems and we can verify. Instead that I could do the SA 01 here, and now if we see docker ps-a would list all the containers, and we should have a container here. Yeah, that one is the container, our ABAP container. This is one host. We have SA02, that's another host, and we can do the same thing here as well. Follow, we can check with the follow log. So container exists, otherwise it would have written an error message, but it's not showing follow. But we can verify docker ps-a. Now I'm running 3 heavy resource incentive processes, 1 VM and 2 containers in my hypervisor, so it will take some time to adopt resources. So it's A4H, there is a container, indeed there is a container, it's running. And then the last one is D03. Again we can verify, and we can see it's active right now and it's running. Now we can follow these containers by running command docker logs A4 container name and follow. This will give us current status of that container deployment process. Now as we can see here, this part is already executed. We accepted licensing terms by passing a parameter, which we can see it here. And now system is starting HANA-DB. The same thing if we go on other host or other LXC container, which is 1 and 2, and we'll call follow, same thing, docker logs A4H follow. Here also we can see the container is starting right now. I will open another session here. Let's log in there, and we follow here as well, docker logs A4H, which is the container, and follow. Okay, so what we did with this Ansible playbook is we deployed 3 ABAP container or 3 ABAP instances by running just one playbook or one command. Now if we want to, let's say, scale with more containers, we could just add another host, and then you just run the script, run the playbook, and this playbook not only deploys containers, but it also prepares the environment required for Docker container, which is basically install prerequisite packages, then install Docker package itself, downloading it from a Docker repository, add that repo, and once we have everything, then create container or deploy ABAP container. So instead doing it on each system individually, this is a lot simpler by using Ansible. Also it maintains the state. So let's say if you remove a Docker C or Docker container environment and you run Ansible playbook, it will put it back, because the way we set up our task here, we are giving state as present. That means we have to Ansible will make sure that the package presence or is available in that system, in short. So we can see here this container has started, which is in Debian-based system. This one also started. So now our let me see if I can get SAP GUI. Before that, okay, so our systems are up and running. Let me do a quick change, because I changed my SAP GUI file, SAP GUI and bin GUI start, I suppose. This is strictly not required. It's just because my laptop has is this one? No, it's a 4K monitor, and SAP GUI is based on Java, which does not really render properly. So what I need to do is add a parameter so it renders properly. Yeah, that one. That line. And that line. So I will comment this line, and then I will remove this parameter. This is basically telling SAP GUI to use scaling 2x. That's all. Okay, now if I launch, it should adapt according to the screen. And since we don't need this, we can just remove that one. That one too, we don't need it. What happened? Is it launching somewhere? No, it seems something is broken. Okay, home, no. SAP clients, SAP GUI, bin, SAP GUI and bin, SAP. We need to run GUI logon. Syntax error. Okay. Nano GUI. This is not required, or is not part of multi-deployment strategy. It's just that my okay, it's not, do not copy the entire path. Okay, now it's good. Let's get rid of that and remove the UI scaling one more time. Now this time it should work. Okay, it did work. It's popping out on another monitor. Let me drag that thing here. Okay, so we have SAP GUI. We'll copy, or let's duplicate this and edit. We'll call SA01, which is our host. That's SA01. Save. Let's make another copy. Edit. SA02. 2. And copy. Edit. DSA033. We need D here. 3. Save. Now if I launch SAP, we should have a fully functional environment. So this is 1, which is SA01. I can run SA02. Now we have here SA02, and this is D3. That's D3. So with a single playbook, we were able to deploy 3 SAP ABAP container instances. Okay, the playbook which I used for this demo will be available on my GitHub, and you can find the link below in the description.